This is a muon. It is an elementary particle similar to an electron but with a much greater mass. Muons are formed when cosmic rays collide with the atomic nuclei of molecules in the atmosphere to form pions. These pions then immediately decay into muons and other particles. A muon particle has a lifespan of about 2.2 microseconds before it decays. 2.2 microseconds is around 0.00000022 seconds. To get a better understanding of how short 2.2 microseconds is, let's look at this example. In 1 second, light is able to travel around the Earth approximately 7.5 times. But in 2.2 microseconds, light can only travel a maximum distance around 550 to 650 meters. A muon particle can travel near the speed of light. And if you do the math, it should say the muon can only travel 550 to 650 meters in its entire lifespan. But however, around 10,000 muon particles hit the surface of the Earth, which is about 50 to 60 kilometers from the atmosphere. You may wonder how the muons cover these distances in their lifespan. There are two explanations for this. The first one is time dilation. When an object moves really quickly, time around it goes slow. This muon travels near the speed of light, so time around it must go really slowly. Time gets extended, so from our point of view, the muon survives for a way longer time, around 220 microseconds. Now the muon has enough time to cover the distance of around 50 to 60 kilometers. The second explanation is length contraction. From the muon's point of view, the Earth is the one moving towards the muon at near the speed of light. Length contraction is basically the length of moving object gets contracted. However, this effect can only be noticed when the object moves at really high speeds and not normal objects which move at everyday speeds. Here, the Earth is the moving object, so the length of the Earth gets contracted. So the distance between the atmosphere and the surface of the Earth also gets contracted to around 500 to 600 meters. Now, the muon can easily cover this distance even in its lifespan of 2.2 microseconds. What are the uses of these muons, you may wonder? There are two main uses for these muons. One is to investigate molecular dynamics, and two is to understand hydrogen behavior in certain materials. And according to this website, muonsources.org, the study of muon gives us unique information to solve global challenges like energy, environment, bioscience, and etc.